Today the topic of discussion is quicksort. So if I talk about quicksort is generally considered as one of the toughest sorting algorithm according to the people. But let me tell you, my dear, I'm going to make it one of the simplest sorting algorithm for you. Let's start. Quicksort. The definition says like merge sort. If you know merge sort, then it's very fine. If you don't know, then need not to worry about that. Like merge sort, quicksort is divide and conquer algorithm, as we have already discussed in binary search. That binary search was also a divide and conquer algorithm where we divide a sequence of array and then we sort and then we solve. Okay, in a similar fashion, quicksort is also based on the method of divide and conquer. Okay, it picks an element as pivot and partition the given array around the picked pivot. So what generally method take place is that here we pick an element as a pivot and partition the given array around that pivoted element. Okay, there are many different versions of quicksort that pick pivot in a different ways. So there are different method of picking pivoted element. Let's see what are the different method. Always pick first element as pivot. You can pick first element as a pivot. Always pick last element as a pivot, or you can pick last element as a pivot. Implemented below. Just I'm going to show you. Pick a random element as a pivot. You can pick a random element. You can pick any element as a pivot. Okay, then this diagrams clearly shows you that here in the given diagram, if I talk about this array, first array, I have few elements and I took this last element as a pivot. So after taking this last element as a pivot, I'll find this seventh position. So what I'll find in second step, what is there? You can see that seventh up is in a place where all the element less than 7, that the element which are left to 7 are less than 7 and element which are right to 7 are greater than 7. This means that list is not sorted yet, but 7th has acquired its position. Now list is divided into two parts. Because of this is called divide and conquer method. Now we have list 1 and we have list 2. Now again we'll perform the same method. Suppose in the given list 1 I have selected 5 as a pivot element. So now I will arrange this entire list according to this pivot element. So on dividing the list, what I found that 5 is arranged, the element which are left to 5 are less than 5 and element which are greater than 5 are on the right of 5. Similarly, if I talk about list 2, I am considering 10 as a pivoted element. Okay, then what I am doing is that element which are left, there is nothing left. So there is only element which are right. So element which are right to 10 is element greater than pivot element. Okay, so hope you understand the basic concept of quicksort, what I was trying to tell you. Let's move further. Description of step manually of quicksort. So a description of each step. So what I'm going to do here is that I'm going to explain each and every step of this quicksort very clearly manually. In all other video prior to this video, first I showed you the animated concept, the automatic step, and then I have shown you the manual step. In this quicksort, what I'm doing is that I'm taking this manual step first. So let's start with the manual steps. So what is there? The element, I'm inserting this element. The first element is 10, then 7, then 6, then 1, 9, 3, 5, 8. That total element, we have 8 elements in the list in an array. And why this extra element, I'll just explain you. Why this extra index, I'll just explain you. So let me change the color of my pen so I can explain you the things very clearly. Okay, now there are 2 pointer. One pointer is J. The J pointer will point to the first position of an array, and there is a pointer I which will point to the position which is just less than J. So what is 1 less than J is 0. If suppose J start from 0, then I would have been -1. Okay, so what I'll do, I'll make this 8 the last element. I'm making this last element as a pivot element. So I'm making this element as a pivot element. Fine. Now what I'll do, I'll start comparing. My job is to partition this array. My job is to find a suitable position of 8, because the element which we have selected is 8, and now my job is to provide a exact position of 8. What I'll do, see the process. What I'll do, I'll compare AJ. What is AJ? 10. I'll compare AJ with pivot. If this element is less than, if this element is less than 8, what I'll do, I'll increment I. Since this element is not less than pivot, I'll simply increment J. Okay, need not to worry, I'll explain you again. Again, what I'll do, I'll compare this element 7 with pivot element. Since this element is now less than pivot, what I'll do, I'll increment I. I will come to first position and I'll swap I and J. So what will happen? 7 will come over here and 10 will come over here. Fine. So 7 will come over here and 10 will come over here. Fine. Okay. Again, what I'll do, I'll increment J. I'll again compare this element with pivot element. If this element is less than pivot, yes, less than pivot, I'll increment I. I will increment I, and what I'll do, I'll swap AI and AJ. So the moment I'll swap, 6 will come here and 10 will come here. What I'll do next, I'll increment J. I'll again compare this element 1 with pivot. Is this less? Yes, this element is less. What I'll do, I'll increment I and I'll swap I and J. The moment I swap I and J, what will happen? 10 will come over here and 1 will come over here. I'm writing 10. Fine. The 10 will come over here and 1 will. What I'll do again, I'll increment J. I'll again compare this element with pivot. Is this element less than pivot? No, this element is not less than pivot. So I'll not increment I, I'll simply increment J. Okay, what I'll do, I'll again compare this element with pivot. Is this element is less? Yes. So what I'll do, I'll increment I, fine, and I'll increment I and J. I'll increment I and I'll increment I and I'll swap I and J, I and AJ. So what will happen? 3 will come over here and 10 will come over here. Fine. What I'll do, I'll again increment J. Fine. I'll again compare it with pivot. Is this element less? Yes, less than pivot. What I'll do, I'll increment I. I'll first increment I and I'll swap what? I and J. The moment I swap, 5 will come over here, and what was there prior to this? 5, and there it was 5. I've just forgotten. 9 was there. 9 will come over here. Fine. So 9 will come over here. Fine. I've just swapped. Now will I move further? Will I increment J? No, I'll not increment J anymore, because the J will move till the element less than pivot. So since the pivoted index is 8th index, so I can move J till the element less than, to the index less than pivoted index. Okay, so our loop will stop here. So the moment loop stops, what I'll do, I'll swap. See, very important. What I'll do, I'll swap. I'll swap AI plus 1. I'll swap AI plus 1 with a pivot. I'll swap AI plus 1. What is AI? I is 5. 5 plus 1 is this. I'll swap this element with this element. So the moment I'll swap this element with this element, 8 will come over here and 10 will come over here. So what happened? What actually happened? Let me show you now. 8 has acquired its position. Now let me rub all these things. 8 has acquired its position. See this. All the elements which are less than 8 are on left of 8. And all the elements which are greater than 8 are on right of 8. Is my array sorted? No, my array is not sorted, but my number 8, the element which I took as a pivoted element, is sorted. Now we have sorted 8 sorted. So now list is divided into 2 parts. Which part? This part. This is what list number 1. Let me make it very clearly for you. So what is this? This is what list 1. And what is this? This is what list 2. This is list 1. The entire list is divided into 2 parts. List 1, and now this is list 2. Fine. So list is divided into 2 parts, list 1 and list 2. What I'll do, I can select any list. I can select list 1. Sorry, this is list list. I can select list 1 or I can select list 2. Suppose I'm selecting list 1. So what I'll do, I'll again make this 5 as a pivoted element. Okay, I'll make J over here, I over here, and again I'll start the process. What will happen? 5 will acquire its position and list will again divide it into 2 parts. So by doing this, to the number of times, what will I'll finally do, what will finally happen, the entire array will get sorted. So let me show you the steps. See the step. 13 is the pivoted element. Hope you're understanding what I have just told you. Since 51 is greater, it will again smaller part and left part. Watch it again. I'm not going to explain you anything. I'm just telling you pivoted element is 13. So finally what will happen? Swap pivot and smaller and greater. So this was about the animated part of quicksort, and let me tell you algorithm of quicksort. Okay, fine. So we have an algorithm of quicksort where a quicksort function is called having three parameters, having three arguments. One is array, one is low, and one is high. So there are three parameters in quicksort function. One is array, entire array, one is low index, and one is high index. Okay, if low is less than high, the moment till when the low is less than high will execute these three functions. That is, recursion is occurring. We are calling three functions. One is partition, and after partitioning we are getting the position pi. What this partition function is returning, this function is returning pi, and on the basis of pi we are again calling a quicksort function. Quicksort function, one list which is less than pi and one list which is greater than pi. So hope you will understand this once I explain you. We have an array, this we have already worked on this array, and this array I'm going to write this array 10 7 6 1 9 3 5 and 8. Fine. Okay, and we have this partition algorithm. Okay, so I'll explain you each and every steps very clearly. So I'll explain you each and every steps very clearly. So let me change the color of my pen and let me make it what color do you really like? Okay, let me take this color, you will feel it good. Okay, so what I'm doing, I'm calling, first of all, my job is to my job is not to partition, my job is to sort this array, and sort this array using what? Quicksort. So what I'll do, I'll simply call quicksort. Yes sir, I'm passing you this array. Okay sir, I'm passing you low. What is low? This starting index is called low, so I'm passing this one. Fine sir, I'm passing high. What is high? 8, the last index. Okay sir. So the moment I'll go inside, I'll check, is low less than high, is 1 less than 8? Yes, condition becomes true. The moment condition becomes true, this entire thing is divided into three parts. One is partition function, another is quicksort, another is quicksort. So the moment I'll start executing, first statement is partition. So I'm calling partition function. What I'm doing, I'm passing array a, low is 1 and what is high? 8. So the moment I call this function, it will jump to its definition, this part. Array will have a value, low will have 1 value, and high will have 8 value. Fine. Till now, hope everything is fine. And let me show you the algorithm. As I've already taught you everything you know very well. And now you're going to see the coding. Okay. What I'm doing, I'm making pivot is equal to array high. What is array? What is array high? Array 8. What is there in array 8? Array 8 has 8. So this element is now passed to pivot. So this element is now pivot. P-I-V-O-T. This element is now pivot. Fine. Very fine. What is I? I is low minus 1. What is low? 1. 1 minus 1. Fine. 0. This is what I already told you, that I will start from 0. J will start from low. What is low? 1. Okay, so J will start from 1. This is what I already told you. J will go till high minus 1. What is high? 8 minus 1. What is high? 7. Till 7. And this is what already I told you, that in first it will go till less than the pivoted index. Fine. Okay, let me start and explain you everything. What I'll do is low is 1. Yes. 1 is less than 7. Yes. I'll check, is array 1 is less than pivot? Array 1 is 10. Is less than pivot. 10 is not less than pivot. 10 is not less than pivot. So what I'll do, since 10 is not less than pivot, so I'll not execute these two statements, because these two statements are a if statement. I'll not execute these two statements. What I'll do, okay, I'll not execute these two statements and I'll come out of the loop. And what is out of the loop? This line is out of the loop. I'll simply come out of the loop and I'll increment J. This statement is out of loop. This statement is out of loop. Okay, so I'll simply come out of if loop and I'll simply come out of for loop and I'll increment j. So j which was 1 now becomes 2. Okay, fine. So I'll increment j. This is what I already told you. Again, what I'll do, I'll check is array j, array 2 is less than pivot. Yes, array 2 is 7, it's less than pivot. What I'll do, I'll increment I, I'll increment I, I'll increment I, I'll increment I, fine, and I'll swap AI and AJ. This is what I already told you. I'll swap. The moment I'll swap, 7 will come over here and 10 will come over here. Fine. Okay, then I'll come out of if block. I'll come out of I will not come out of for loop. I'll simply increment j. The j becomes now 3. Fine. Is 3 is less than 7? Yes, 3 is less than 7. I'll check. Is a3 is less than pivot? A3 is what? 6. Yes, 6 is less than 8. 6 is less than pivot. What I'll do, I'll increment I. Okay, fine, sorry, let me increment j first. J has become 3, j, because this value is j has become 3. Is AJ, is A3 is less than pivot? Yes, A3 is less than pivot. What I'll do, I'll increment I. I'll increment I. Okay, and what I'll do next is swap AI and AJ. So I'll swap. The 6 will come over here and 10 will come over here. Fine, 10 will come over here. What will I'll do? I'll again increment j. J will become 4. I'll check 4 is less than 7. Yes. I'll again check is A4 less than pivot. What is there in A4? J has come to 4th position. Okay, J has come to 4th position. I'll check is AJ is less than pivot. Yes, it's less than pivot. What I'll do again, I'll increment I. I'll increment I and I'll swap. I'll swap this statement. I'll swap this statement. I'll swap AI and AJ. So what I'll do, I'll swap. 1 will come over here and 10 will come over here. Fine. So I'll swap this. Okay, what I'll do again, I'll increment j. J becomes 5. I'll check 5. J become 5. So let me move this j to 5. I'll again check is 5 is less than 7. Yes. I'll check is A5 is less than pivot. What is there in A5? 9. 9 is less than pivot. No, 9 is not less than pivot. So I'll not enter this if block. I'll simply come out and increment j. Now j becomes 6. I'll check j becomes 6. Let me increment j. I'll again check is A6 is less than pivot. What is there in A6? 3 is less than pivot. Yes, it's less than pivot. I'll increment I. I'll increment I and I'll swap AI and AJ. So the moment I do, 3 will come over here and 10 will come over here. Okay, what I'll do again, increment j. J becomes 7. Fine. I'll check 7 is less than 7. No, but it is equal. So j becomes 7. Condition again true. What I'll do again, check is array j. Is array 7 is less than pivot? Yes. I'll increment I. I'll increment I. Fine. What I'll do, I'll swap AI and AJ. The moment I swap, what will happen? 5 will come over here and 9 will come over here. Fine. I'll again increment j. The moment I increment j become 8. Since 8 is not less than 7, condition false, I'll come out of the loop. Come out of the loop, means I'm out of this loop now. Now the next line is this. What I need to do is swap AI plus 1. This is what I already told you. What is I? I is what? I is 5. 5 plus 1. What is 5 plus 1? 6. I'll swap A6 with A high. What is high? High is still 8. What is high? High is still 8. So I'll swap A6 with A8. The moment I'll swap A6 with A8, 8 will come over here and 10 will come over here. Let me rub all these things now. Okay, fine. So, and what I'll do on doing all these things, I'll return I plus 1. What I'll return I plus 1, I is what? 5. 5 plus 1 is 6. So where I'll return? I'll return here. See this. I'll return to this. I'll return to this. I return 5 to this. I'm returning 5 to this. I'm saying, hello, you called me for partition? He said, yes, sir. So I did the partition. He said, okay, sir. So what I'm returning is you that no, I plus 1, 5 plus 1, I'm returning you 6. Sorry, I'm returning you 5 plus 1, that is 6. He said, so current value of PI is 6. So current value of PI is 6. So you can see that all the elements which are less than, which are less than 8 are on the left of it. I can show you that all the elements which are less than 8 are on the left of 8 and all the elements which are greater than 8 are on the right of 8. Fine. So pivot element is on its fixed position now. What will happen now? See, the list is divided into two parts. Fine. Okay. So list is divided into two parts. That is pi. Now pi has value 6. So I'll again call quicksort. I'm calling quicksort for array. Array is array. Low is again the same. Low is not changed. Low is 1. But high is now pi minus 1. What is pi? Pi is 6. 6 minus 1 is what? 5. So have you seen the beauty? Again I'm calling quicksort for what? 1 and for this position, and this is what? List 1, and this is what? List 1. And in next what I'm doing, I'm calling array pi plus 1. What is pi? 6. 6 plus 1 is what? 7. And what is high? 8. So I'm calling a quick sort from 7 to 8. 7 to 8, this means I'm calling from here to here, because 8 is already sorted. So this is list 2 and this is list 1. Fine. So this process will keep on continuing till low is less than high. Till low is less than high. So what actually happens here? Let me show you. The moment first of all I have called quicksort, I have passed 1, I have passed 8, and I have passed 1, I have passed 8, I have passed array, I have passed 1, and I have passed 8. What happened? It has called 3 function. One is partition, that is pi equal to partition array 1 8, and on the basis of this pi, what I am doing is that I am calling again quicksort. What? I am passing a, low is same, but what is high? Because list is divided into 2 parts. This is pi minus 1. One list is this, and one list has become array. One is after that pi. What is pi plus 1 until maximum element 8. So this is actually taking place. So let me give you the real example. So if I take the real example, pi value is 6. So this will break into a 1 5, and this will be a, then 6 is 7 and 8. Fine. Again what I'll do, I'll again call this quicksort. I'll first call this quicksort, then it will again call pi is equal to partition, then array, low, high, and on the basis of this pi I'll divide this statement. The moment I'll keep on doing this, my array will get sorted, and finally I'll get the sorted array.